Hi, I'm in the Paxton workshop and I'd like to talk to you about our latest version of Net2 software, memorably called version 4.24. We have a lot of features in version 4.24, but the main change in the software is the robustness and its suitability to large sites. And I'm in the workshop with our test rig in order to demonstrate that for you. So let me introduce you to the test rig. We have 500 wireless control units on this side and 500 on this side. You can see they're mounted in stacks of 5 control units. It's an absolute nightmare scenario for a wireless control unit because they're all in the same place. They're all stacked tightly together. So it's a very good test rig. Now these wireless control units are communicating to the PC via 50 Net2 bridges. Now these bridges, you might be able to get a close-up of this. Again, they're stacked on top of each other in PCB form. So again, very difficult wireless conditions, which is exactly what we want to see. The last part of our test rig is 200 Net2 Plus control units. These are all connected directly into TCP/IP network and then go straight onto the system. So again, each one of these is connected, its own TCP/IP connection, and together this whole rig we've got 1,200 doors. So it's quite a setup. You can imagine it's a huge site that we're replicating here, and it's fascinating how the software copes with it. So what I'd like to do is show you on the software how it deals with a site like this. So I'm at the server now, the Net2 server PC. This isn't a super duper PC or anything like that, it's a pretty run-of-the-mill spec PC. I can see that all of my 1,200 doors are online, they're all responding correctly, they're reporting events and they're doing what they should do. Importantly, you should be able to see the CPU usage of the PC. It's currently running at 17%, 16%. Now, that's what you would expect, really. This thing isn't struggling to cope with the communication to this massive site. You want it to just be handling it in its stride, and that's exactly what it's doing. That certainly wasn't the case before. So let's have a look and see how the CPU and how the system copes with some activity on the site. I've got a token here. Now, each bank of these control units is wired into a single reader. I'm not sure if you can see that down there. So that when I present this card to the reader, it simulates 25 cards being presented to 25 different doors at the same time. So if I go along like that, I've just generated 600 events or something. If I go back to the PC, see my events coming in, actually access denied. So everything's responding as it should do. I can see that the CPU of the PC, this thing isn't breaking sweat at all. Everything's just working exactly as it should. So let's try a slightly more difficult test. Let's try opening every single door on the complete site at the same time. If I go to the open door wizard, I select all of these doors and I click finish. We should hear lots of clicking. Okay, this is great. So, got all the doors opening exactly as requested. We've got the events piling in, so door open with network instruction, exactly what we'd expect. And then we've got on the CPU meter, it's going up to, yeah, again, it's 20%, maximum 25%. So let's go a stage further. What would happen on this site if there was a major power outage? That's going to be interesting to have a look at. So will it cope? I'm actually just going to unplug half of the bridges we've got on here. fast forward this bit if you want. That was fun. Right, what damage have I created? So, as expected, we're getting lots of control units offline. If I look at the door screen, I can sort by status. I can see all of the control units that are not responding. So what we'd expect to see over the course of the next few minutes, if the system is handling it properly, we should see the control units that have lost their bridge. We should see them taking the considered decision, right, I'm not going to be able to communicate with that bridge anymore, I'm going to go to the next one with the strongest signal. They don't do this immediately because you actually don't want your control units flitting about between different bridges, you know, whenever somebody walks down a corridor. So try several times before actually changing over. So we'll be able to watch these things coming back online. Okay, so after a wait of around, what's that, 5-10 minutes, something like that, all the control units that have been disconnected because of the power outage on half the bridges, they're all back online. They've actually bound to the other half of the bridges that are still online. They're all now communicating, the whole system is working effectively. It's worth saying actually that even while some of the control units were offline, they were still doing exactly what they should do as far as the user is concerned. So if somebody goes up and presents a token to that control unit, it will still be granting or denying access and letting them in and recording the event. But now as far as the system is concerned, everything's back up and running. The CPU, you probably saw throughout the process, again, the PC is not stressed, even with this big power outage, a major event in the system, it's just handling it, there's no problem. And if I present my token to the readers down here, I can see, I can see events coming straight in, so everything's working as it should do. So, good news. So in addition to the scalability and robustness of the software, we've also added some features that make handling large sites much easier. One of these features is door grouping. So in the past within Net2, you've had to have a flat list of doors, and it's fine if you've got 20 doors or 30 doors, but if you've got 1,000 doors, then it's just not practical. So a fairly simple thing, but we've added the ability, you can see here, to group doors. So here we've grouped by the board number. So we've got all these different boards here, so I can see all of the control units attached to board 10 and get a breakdown of those. In a real site, it would be much more likely that you'd group them together by building or by wing or by department or something like that. So from an organisational perspective, it's just much easier to group them together. From an installation perspective, you can right-click on the group name in the tree view, and you can actually select group properties. So if you want all the control units within a certain building to have a certain door open time, or you want to quickly set up multiple control units, then you can do that by group. So again, that's a nice feature. Now, another feature that really makes handling of these sorts of sites much easier is something we're calling advanced access permissions. With Net2, we're very, very reluctant to add niche features for, big projects that make life complicated for the majority of people who just want the system to be very simple. So we've made advanced access levels something that you opt into, and what it allows you to do is you can combine multiple access levels on a single person. so that they could have multiple roles within a company, for example, and get the combined level of access. Now, since we released Paxlock, a new door handle product, we've been involved in more and more large project specifications. A typical example would be halls of residence. And in a halls of residence, you might have 20 common doors that everybody is allowed through, and then you might have 500 bedroom doors with Paxlock devices on. Now, the way you used to have to set this up before this latest version is that every student would have had to have individual permissions. So you would give them access to the 20 doors plus their individual room door. Now, with advanced access levels, what you can do is you can group the common doors together as an access level, and in addition to that, just add individual permission for their individual door. And that means that if you were to add 2 extra common doors, you don't have to go into every individual student's record in order to add those 2 additional doors. You just change the access level, and that will affect everybody else. So I can show you how that works in reality. So let's select a user. We can see here Ruby Johnson. We can see access level list view here, and we can see individual permissions here. So if I wanted to give Ruby Johnson working hours access level, I can do that. In addition, I want to specifically give them access to 1 or more control units, then I can do that. And I can actually set the time zone for the additional control units. So I can say, okay, they're allowed in this one at working hours and these 2 all day, every day. So I can tailor exactly the access levels and the permissions that I want for each individual, and it's just a nice administration tool. So I'll apply that. The final feature that I wanted to talk about is more of a background thing, but it comes back to this robustness thing, and it's channel changing for wireless control units. It's more and more the wireless environment is highly used, so people streaming media over Wi-Fi to iPads and iPhones and internet TVs and that kind of thing. It's only going to get worse. One of the ways that we're addressing that is by adding in an installation option which allows you to configure what part of the 2.4 GHz spectrum you actually want to use. So if you have a very busy part of your frequency range in your environment, you can change between channels 11 to 25. The wireless technology we use is designed to coexist with Wi-Fi, but this extra step just makes it even more robust. So there's lots more I could talk to you about, but I want to keep it short and sweet, so thanks very much for listening.